Okay, let's talk about the concepts of congruence and similarity. First off, congruence. What do we mean by the actual term congruent is identical. So if two shapes have congruence, that means that they are identical in every way. So this is called a congruent statement, and a congruent statement tells us how they're identical. So the order matters when you're talking about a congruent statement because that tells you exactly which pieces are the same. Side AB and side EH would be the same. If you're talking about angle C, would be identical to angle G. So not only it tells us that they're identical, but it tells us how they're identical. So we know that if we knew the length of BC here was 8, you can locate where BC is at, and you know that HG is also has a length of 8. You could do the same thing with angles. We knew that angle F is maybe 40 degrees. Then we can look over and see what it corresponds with. And since D is in the same place, we'd know that it was also, and that's supposed to be a D, would be equal to 40 degrees. Now we also have similarity. And what we mean by similarity is they're the same shape, but not necessarily the same size. They're identical in shape as far as they have the same ratio is what we're going to say. However, they're not necessarily the same size. There's going to be a different ratio. So a similarity statement works the exact same way a congruent statement does. It tells you what side lengths are proportional, what side lengths go together, such as here, side length AB for my first drawing would be proportional to RS. Now, this ratio that we're talking about tells us how much bigger or how much smaller a shape is. Sometimes it's helpful to actually take a ratio and turn it into a scale factor by dividing the two numbers. 3 divided by 2 would give me a 1.5. Or if I did it in the other direction, 2 divided by 3 would give me 0.6 repeating is what it would give me. So therefore, what that means is this ABCD is 1.5 times bigger its side lengths are. Side lengths are 1.5 times bigger than RSTU, or you could work that backwards. And if we were to multiply all the side lengths of ABCD by this 0.6 repeating, that would give me the side lengths of RSTU. So not only does it tell you which sides are proportional, but it also tells you how much bigger or how much smaller they actually are. Now, one thing we do need to know about similar shapes, even though their side lengths are not necessarily the same size, their angles, however, will be identical. And let's see if I can actually do this. If I were to take and scoot this over, we can see that those angles actually line up. And I can do that for all 4 of the angles. So even though two shapes might have different side lengths, if they're similar, they're also going to have the same angles. So therefore, if this is a 40-degree angle, and we know that D lines up with U, then this would also be a 40-degree angle.